Hi, so today I'm going to be discussing the difference between AC and DC, the two different types of electricity. AC stands for alternating current, which is what you find out of your wall outlet, and DC stands for direct current, which is what your laptop, your computer, and your cell phone run off of. I want to talk about the upsides and downsides of each type and why they're used in their particular applications. So I'm going to show you a very, very terrible picture that I found quickly on Google Image Search over here so that I don't have to make my own, because my own will look even worse. So this picture over here gives you a good idea of the difference between AC and DC. So AC is on the right and DC is on the left. So this looks kind of like a line graph. Now in the middle over here you have 0 volts. So this line over here, right here on the y-axis represents 0 volts. Above it is going to be a positive voltage and below it is going to be a negative voltage. So here let's just assume that this is 100 volts of DC. So direct current is, for lack of a better way to say it, straight. It's a straight line. It's direct. See, it's 120. It's flat. It's a constant. Let's say this is 100 volts. It's a constant 100 volts going flat. And it's always going in one direction. So it's positive. So this here is positive. So that's 100 volts positive electricity. Now over here on the AC source, let's say this is 120 volts like what comes out of your wall. So it's not always 120 volts. See, it's starting and then it moves up to the top. This would be considered 120, and then it goes down back to 0. Then after going down back to 0, it goes to minus 120, and then it continues waving back up to 0, and then it's just going to keep going. And this over here is the cycle count, or the frequency count. So in the United States, in a wall outlet, you have 120 volts at 60 hertz, meaning that this waveform, you're getting 60 of these per second, and the voltage is 120 volts. The reason AC is used for wall outlets is fairly simple. It's easier to transport a waveform than it is to transport a straight line. So if you want to carry power through long distances over power lines from a power plant hundreds and hundreds of miles to your home, what do you think is easier to transport? A flat line or a wave? The wave is easier to transport. It travels easier. Now, when it comes to your cell phone or your computer or a speaker amplifier or anything like that, here's why DC is better. Now, let's assume you know nothing about how digital circuits or computers work. I'm sure at one point in your life you've heard that computers work off of something called binary, that all types of digital circuits work off of some type of binary, which is 1 for yes and 0 for no, or the other way around. So you have 1 and you have 0. And it's a combination of these ones and zeros in very, very creative ways that allow you to see a digital image of me on a screen, that allow you to go on the internet and do all these things. A computer pretty much works off of basic digital circuitry of ones and zeros. You have millions and millions and millions of transistors switching these ones and zeros around in, again, creative and crazy ways in order to, use the internet and print out things and watch YouTube videos. But for the most part, a computer and digital circuitry works off of a 1 and a 0. Now, what do you think is going to give you a better reference of ones and zeros? Like you need a yes, you need a 1, and then you need a 0, you need a no. What do you think is going to be easier to allow you to reference that? Going back to here. In the DC circuit over here, you have a flat line over here, whether that's 100 volts or 1 volt. That could represent yes, and then you have the 0, which could represent no. Now with the AC source, it's a constantly moving target. So again, you want to have a constant 1 and a constant 0 for your digital circuit to work properly. But what is this? Like this, is this a yes or a no? Is this a yes or a no? Like what is this? Like it's a constantly moving target. Even though it averages out to 120 volts, there it's 119, 118, 117, 116, 114, then it's 0, then it's going back up and down. This is a mess. If you want to know whether something is a yes or a no, if you want to have a constant reference, then this is bad. Now, the same thing could be said for, let's say, a musical amplifier. So my amplifier down here, the way it works is you take an input signal and then it wants to modify a bigger signal to create the output signal. So let's say I take the tiny signal out of my cell phone, I plug it into the amp, and then I get a big signal out of the speakers. What it's doing is it's taking a really high power level and it's modulating that high power level based on the tiny one. So it's turning this high power, this high, like let's say 70 or 80 volts, into a waveform for my speakers based on the 0.5 or 1 volts that comes out of here. Now again, I know what I want in my output. So what do you think is going to be better? When I know exactly where I'm starting by using a DC power source and modulating this, or this? Again, the DC source is what I'm going to want from my amplifier. My amplifier, even though it has AC input from the wall, it turns that into DC, and then the entire circuit runs off of DC. If you know what you want your output to be, if you know what you want to create, and you don't want to try to be creating that from moving target. Trying to create an amplifier that runs only on AC, it would be kind of like trying to paint on a canvas when the colors are moving around the canvas as you're working on the painting. It's impossible. That's why amplifiers and things of that nature run off of DC and not AC. So again, if you know what it is you want to create, if you know I want to create this out of this, you don't want this to be something that's constantly changing, because then how are you going to take that and turn it into something? You would rather turn something that's constant into your output rather than turning something that's constantly waving into a specific output. Again, it would be like me trying to sign a check and somebody's moving the check back and forth as I'm trying to sign it. It would be a pain in the ass. I'd rather just have the check sit on the desk. Same is true here. If I know that I want a 1 on output, I don't want to be using an electricity typer. Instead of it being 1, it's 1 0, 1 0 minus 1, 1 0 minus 1, 1 0 minus 1. That would be a pain in the ass. So in order to have cell phones and computers and everything work and our amplifiers work, we don't want to use AC, but we need AC in order to get this power into our homes in an efficient manner. Now also, you may see some devices where there is no AC to DC conversion and they simply work off of AC. Now, devices where you don't care about producing a specific output, where you don't want a specific mathematical output, like this input signal needs to turn into this output signal, that is where AC is just fine. If you want to run, let's say, a heater, AC is just fine. You don't care. All you want is for the power to make the thing hot. You don't need a specific output result. If all you want is for a motor to spin, you don't need DC for that. AC will be just fine. All you need is for it to spin. It doesn't have any actual thinking to do. So a best way to think about it is when you need the device that you're using to do any type of thinking, and I put thinking in quotes because this is really all programming. It's not thinking. But when you need it to do what you would consider thinking, you need direct current. When you need it to pretty much just do something with brute force, like heat something or chill something or move something, AC is just fine. Now, what I'm going to talk about in the next video is ground. Now that you have an understanding of what AC and DC are, what the two different types of electricity are, and what they look like, we're going to move on to ground, which is something that you need in order for any circuit to actually work.